In this lesson, the 10th lesson in measurement, we're going to look at surface area. Surface area is the number of square units needed to cover the surface of a three-dimensional object. So now you'll see that we're working with three-dimensional objects. And if you think of surface area, think of having to paint the outside of that, or to how much wrapping paper would it take to cover all of the surfaces of that shape. So let's first look at some of these shapes or objects and start naming them. It helps to think about them when you know the names. And some of them, especially if they're regularly shaped, will have formulas, and many of them will not. And we'll look at some examples so that when a formula doesn't fit, we know how to use it. So the first type of objects that we're going to look at are prisms. And a prism is a shape that's got lots of right angles in it, and think of it as a loaf where if you slice along it, every slice is exactly the same size and shape. So this prism has a rectangular base, this one has a square base, this one also has a square base, and the sides are the same. The height is exactly the same, so it's actually a cube, which is a type of square-based prism. And this is a triangular-based prism. So the base is a triangle, but all the other sides are rectangles. A cylinder is like a prism, except that the base is a circle. So if you flipped that over and sliced it, you would have circular slices, and they'd all be exactly the same size. A pyramid, on the other hand, has a point, and we're only going to look at pyramids where the point is directly above the center of its base. And we've got pyramids that have a square base, pyramids with a rectangular base, a pyramid with a triangular base, and a cone is like a type of pyramid where the base is a circle and everything goes up to a central point. And then the last 3D figure that we'll look at is a sphere, which is like a ball. Okay, a couple of definitions, or really just one, and that is a net. The net of a solid or a net of an object is created by making cuts along some edges and opening it up to form a flat figure. Based on this definition, then, a net can be folded back up to create the original 3D solid. You can see some diagrams of nets in your workbook, and one of the examples that we're going to do uses a net in order to solve it. There are surface area formulas in your workbook, and for any shape that's not a regular one, that doesn't fit nicely with one of the formulas, you're going to draw the net first and then find the area of each part. And the parts will be triangles and rectangles, so you know how to find the areas of those, and then the surface area is just the total or the sum of all of those parts. So let's look at some examples. So here we have a rectangular-based prism, and we want to find the surface area of it, and this is one where we can use a formula, and the formula is surface area, and we just use A for surface area, is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. And it doesn't matter which side you call length, width, or height, because you could just tip this block over and it would be the same shape and would have the same surface area. But when you're given the 3 measurements of a rectangular prism, call one of them height, call one of them width, and call one of them length. So when we substitute our values in, we get 2 times 5 times 2 plus 2 times 5 times 3 plus 2 times 2 times 3. And when we add those all up, we get 62 square meters. Okay. Question 2 also is one that we can do using a formula. It says determine the surface area of the basketball if its diameter is 10 inches. The surface area of a sphere, because a ball is a sphere, is A equals 4 pi r squared, which is interesting because pi r squared is one circle, and it's like it's 4 times the area of a circle. Now we need the radius, and we've been given the diameter. If the diameter is 10, then the radius is half of that, which is 5. So our surface area will be 4 times 3.14 times 5 squared. And when we pop that into our calculators, we get 314 square inches for the area of the ball. Oops. Oh, I think I missed one. Okay, example 4, we've got, oh, I know what happened. Sorry here. There's example 3. Example 3, determine the surface area of this cylindrically shaped cup. Notice that that 40 millimeters refers to the radius of the circle. The 95 is our height of the cylinder. And because it's a cup, only one end is closed. If we look at the formula for the surface area of a cylinder, we get 2 pi rh plus 2 pi r squared. But that's for a cylinder that's closed on both ends. This part of the formula is the side. Think of it as the label on the soup can. And there's 2 circles. 2 circles or 2 ends of the can, okay? So if we are using a cup only is closed at one end, so we're going to adjust the formula. We're going to say the area is 2 pi rh, the side of the cup, plus just one circle, pi r squared. So we'll have 2 times 3.14 times the radius, which is 40, times the height, which is 95, plus pi times the radius squared. And when we put that into our calculator, we get 28,888 square millimeters. All right, now we can start example 4. Determine the surface area of the following rectangular-based pyramid. Please note that the heights of the triangular faces are identified with a dotted line. This is one of those cases where there's not a neat formula. So let's draw the net for this shape, and then we can find the areas of the different parts, okay? So the base of this is a rectangle. So there's my rectangle, and it's 18 by 36. Oops. Okay, now from each side comes a triangle, and it's really helpful if I draw them a little bit neater. Okay, and if we were to fold that up, it would look exactly like that one. Now, let's put in the other measurements that we have. We have the triangles that come up from the 36 are 41 meters tall, and the ones that come up from the base of 18 are 44. Oh, I noticed that this has meters here, but let's call them all centimeters so that we're nice and consistent here. Okay, so these are all measurements of centimeters. Okay, now I'm going to just pop a different color in, and let's do the base first. Okay, so area of base. And it's a rectangle, so it's going to be length times width, which is 18 times 36, giving us 648 square meters. Then let's look at triangle number 1, and there's 2 of them. Just note that. We'll just do the area of one of them for starters. So area of triangle 1, and that's 1/2 the base times the height, just 1/2. The base of that is 36, and the height is 41, giving us 738 square centimeters. And then the second triangle, which is the skinny ones that come up from the 18 centimeter side. And again, there's 2 of those as well. So 1/2 the base times the height will be 1/2 of 18 times 44, giving us 396 square centimeters. So our total area is the sum of all of these, okay? So it will be 648 plus 2 times 738 plus 2 times 396. And when we do those calculations, we get that our total area is 2,916 square centimeters. And that's it for this lesson. Have fun with those questions in the book.